Welcome to the lecture series on 8051 microcontroller. Today we'll be looking into the arithmetic instruction set of 8051, and we had actually already discussed add instruction, but we will see today how add instruction is carried out when the numbers are signed. Okay, so let me take an example so that it becomes clear. So let me take one instruction. Say move a comma hash minus 128. Okay, now let me take move r4 comma hash minus 2, then add a comma r4. Okay, so the first instruction so the value a instruction will get this value. Okay, so what is minus 128? Minus 128 is nothing but minus 128 is equal to, if I write it in binary form, 1000 and 0000, or in hex it would be at th. Okay, and similarly the number minus 2 would be, if I write it, it would be 1111 and 1110. Okay, and in hex it will be FEH. Okay, so we have to add these two. If I am adding these two, what I get? I will get 0 plus 0 is 0, 0 plus 1 is 1, 0 plus 1 is again 1, 0 plus 1 is 1, again 1, 1, 1, and 1 plus 1 is 1, 0. So 0 will be here, 1 will be in carry. So CY becomes equal to 1. So what is this number? This number, what is this number? This number is, as you could see, this is a positive number because 0 is coming here. And what is the number? So you can find it out. So here it is 8 plus 4, 12 plus 1, 13. 13 is represented by A, B, C, D. So this is D, and here it is 1 plus 2 is 3 plus 4, 3 plus 4 is 7, 7D. So definitely adding minus 128 and minus 2 won't result in 7D. Okay, so something is wrong. So what is wrong? Basically we are trying to go beyond the limit of minus 128. In the earlier video I told about the signed numbers. So the maximum negative sign number is 128. We cannot go beyond this. Okay, so error is being generated, and that error will be conveyed by the overflow flag in the program status word. So this becomes equal to 1. Okay, so this is a very important thing. Let me take another example. So I take move a comma hash minus 2, move r1 comma hash minus 5, and add a comma r1. Minus 2 is 1 1 1 1 1 1 1 0, and minus 5 is 1 1 1 1 and 1 0 1 1. So if I add these two, what I get? I will get 0 plus 1 is 1, then 0 0 1 1 1 1, and again 1. Okay, so carry flag CY is equal to 1. So what is this number? This is nothing but this is a signed number. Okay, so this is equals to -7. So please remember this is in decimal. Okay, in the previous slide also I took these two numbers, they are in decimal. I actually represented it in hex. It is not in hex, please remember. Similarly here also these two numbers are in decimal, negative signed numbers. Okay, so finally this will come out to be -7. Okay, so and this is correct. So if we add -2 and -5, it will come out to be -7, and here the overflow flag will be 0, so indicating that the operation is correct, no problem with the operation. So let us take another instruction, the add C instruction. Okay, so add C instruction is used to add two 16-bit numbers. Remember, add instruction cannot be used to add two 16-bit numbers. Two 8-bit numbers can be added, either signed or unsigned, but we cannot use it to add 16-bit numbers. We can do it with the help of add C. So let us see add C command. So let me write down one code. Before that, add C, what it will do actually. So if I am writing the syntax a hash, say I am writing here 05h. Okay, so add ca comma hash 05h. So basically it will be storing the result in a. So whatever was there in a, -5 and minus the carry flag. So this sorry, add +05 and plus the carry flag. So this is what is done. So what's the logic of adding this carry flag here? So let me take an example and it would be more clear. So let us suppose I want to add two numbers, two 16-bit number. One number is 25F2 and the other number is 3189. Both are in hex. So if I want to add these two numbers, I definitely have to use two registers to store this 16-bit and this 16-bit number. Okay, so let's start clear C instruction ensures that the carry flag is set to 0. Okay, then move a comma hash 89h. So what this instruction do? A will become 89. Then add C a comma hash 0f2h. So I am adding the lower 8 bits of the 16-bit numbers. Okay, so this is this one, this is this one. So what will be the result if I add these two? Basically what I am doing, I am adding 89 and I am adding f2. So result will be 17b h. So 17b will be stored in a, while this a is the carry, cy equals to 1. Okay, then what I have to do, move r3 comma a. So whatever has come in a now, which is 7b, will be moved to r3. Okay, so now r3 will be having the value of 7bh. Then add c, sorry, before add c I have to write one more instruction, move a comma hash 31h. Okay, so this saves value 31 in a. Then I will be reading again add c instruction, add c a comma hash 25h. Now just see, this 31 is the higher 8-bit of the one of the 16-bit number. This 25 is again the higher 8-bit of the other 16-bit number. I am trying to add these two. So a will store the results of addition of these two. 31 plus 25 will be added, plus a carry will also be added. Here you see, here also carry would be added, cy, but cy is 0 here. But because of the result of this operation, cy becomes equal to 1, and here cy will be 1. Okay, so if I add these two number, it will come out to be 57H. So the number finally will be 57, the higher 8 bit, and 7B, the lower 8 bit. So this is the answer, and it is saved in you can save this value in some other registers also. So move a comma R4 comma a. Okay, so this value 57 is saved in R4. So R3 and R4 will be having the value of the operation. Okay, let's move forward. So let's take another instruction, which is sub B. So sub B is subtraction. We don't have sub instruction in 8051. We have only sub B instruction. So sub B instruction is 16-bit subtraction. Okay. So if you want to do 8-bit subtraction, what we can do? We have to use the same instruction sub B. Okay. Just see how it works. So sub B, if I write the syntax, a comma, say hash 25H. So what this will do, so it will save the value of this operation, a minus 25 minus the carry flag. This will be saved in a. Okay, so if you want to do 8-bit operation, what you have to do, you have to ensure that cy is 0, and then you can do the 8-bit operation also with the help of this sub b instruction. So take one example, simple, move a comma hash 45H. So this puts the value of 45 into a. Then clear C. I'm actually trying to do an 8-bit subtraction here. Then sub B a comma hash 23H. So 45 minus 23 minus the carry flag, which is equal to 0, which I have set, which I have cleared it. So 45 minus 23, you get 22. This 22H is the answer, which is stored in A. Okay, so this is quite simple. So let us now take another instruction which is quite important, which is the multiplication, MUL. Okay, so multiplication has got the syntax like A B, mul AB. This is the syntax of the multiplication operation, multiplication instruction. Please remember that mul operates only on A and B register, no other register. Similarly, I will be talking about div, that also operate only on A and B, and this is quite simple. Mul AB will result in the multiplication of A and B, and the result will be stored in B and A, because multiplication of two 8-bit register will result in a 16-bit register. Okay, so that need to be saved in two different registers. So this multiplication, the lower 8-bit of the multiplication will be saved in A, lower 8 bits in A, and higher 8 bits in B. Okay, it's as simple as that. Let's take one example here for multiplication operation. Okay, so I am taking move A comma hash 10, move B comma hash 15, and mul AB. So this will result in a value of 150. Okay, so now let's talk about div also. So div is basically dividing A by B, and this will result in quotient and remainder. Quotient will be saved in A and remainder will be saved in B, as simple as that. Okay, so I will take it's simple. Okay, so let me stop here.